Ever feel like nature's showing off? While we're busy fumbling with our phones and battling rush hour traffic, animals are building incredible structures with nothing but instinct and raw materials. Forget night vision, flight, or super strength. We sometimes struggle with the basics like feeding ourselves without a drive-thru. Let's be honest, most of us can barely keep our apartments clean, let alone design a sustainable city. So, before you stress about your next mortgage payment, let's take a look at 10 amazing feats of animal engineering that might make you rethink your next home improvement project. 10. Bagworm log cabins. Forget butterfly cocoons. Bagworm moth larvae, like the tiny lumberjacks they are, use what they got: twigs, leaves, whatever's lying around. There are bagworm species everywhere, and their bags, aka cocoons, come in all sorts of styles. Some look like feathery messes, others are like tiny Christmas ornaments, but the coolest are the miniature log cabins. Think Little House on the Prairie, but built by a caterpillar. A study in India found that these little buggers, the Clania crameri species, weren't just slapping sticks together. They had a design in mind. They're out there searching for the perfect length twig to build their spiraling towers. It takes their whole larval life to finish, but it's worth it. The males become fuzzy moths while the females, well, they basically turn into egg-laying machines. Talk about a short end of the stick. 9. Caddisfly submarines. Caddisflies, those moth-looking insects, live underwater as larvae. And this is where they get their creative juices flowing. They spin silk and combine it with sand, stones, and plants to build their own personal submarines. Depending on the species, these homes are either permanent or mobile. Each species has its own unique style. While adult caddisflies can be difficult to tell apart, the larvae can be identified by their homes. Some are smooth, others are lumpy, and so on. Only one larva lives on land, in the leaf litter of the English West Midlands, Enoisella pusilla, the land caddis. All others inhabit submarines. 8. Ovenbird adobe abodes. Ovenbirds, native to North America, get their name from their mud nests that kind of resemble old-school Dutch ovens, if you're standing far away with one eye closed. It takes them around 2 weeks to build these things, crafting the walls from a bowl shape upwards. They use like 10 pounds of mud. That's like hauling around a sack of potatoes. They also throw in plant matter and dung for extra strength, and then line it with grass for a comfy finish. They create a circular opening that acts as both front door and security system, keeping predators out with a curving wall and concrete like adobe. In fact, ovenbirds make 3 types of nests: cavities, domes, and abodes. Cavity nests are commonly established in woodpecker holes. Natural cavities, or burrows as deep as 3 feet, 1 meter. Dome nests are built with grass, sticks, feathers, bones, and other materials. 7. Bowerbird theme parks. Okay, these guys are basically nature's interior designers, with a touch of hoarding tendencies. Native to Australia and New Guinea, Bowerbird are second only to humans in adorning their structures. Their bowers, walls of sticks bent inwards, are comparable to Disney World because of how they use perspective to make everything look taller to attract mates. Bowerbird also fill their yards with plastic tat and mass-produced garbage: marbles, ring pulls, duct tape, bra straps, ribbons, pegs, glass, wrappers, and even syringes. One bower was found to have bottle caps arranged in an arc around a plastic doll splayed in the center, eyes wide and mouth open in a plastic screen. They also include plenty of natural materials: feathers, stones, shells, leaves, flowers, beetles' body parts, and so on. But interestingly, Bowerbird living close to humans show a preference for our trash because they know its color lasts longer. This is important. The objects selected for display are meticulously color coordinated. Blue is the favorite of the satin bowerbird, while the great bowerbird likes purple, red, and green. 6. Sociable weaver apartments. These sparrow-sized birds, native to the Kalahari, weave sprawling communal nests like avian apartment complexes for 100 or so families to live in. Each block resembles a haystack in the tree and follows a typical blueprint. Large twigs are used for the roof, while grasses are woven into the 4 to 6-inch chambers or apartments, which are then lined with soft furnishings like fluff, cotton, and fur. Entrance tunnels can be as long as 10 inches and lined with spikes of straw to keep predators at bay. Further protection from tree snakes and honey badgers comes from the choice of tree. Smooth, tall trunks, or even telephone poles are best. But cheetahs, vultures, owls, and eagles often find their way up to the roof of the complex just to enjoy the view. Giraffes and antelopes love them too. The birds' droppings enrich the soil, resulting in more leaves for food and shade on the trees. The sociable weaver's sociability even extends to other birds. Building more chambers than they'll ever use themselves, they welcome other species to the block. The South African pygmy falcon, for example, depends on their hospitality. Other visitors include the pied barbet, ashy tit, familiar chat, red-headed finch, and rosy-faced lovebird. This benefits the colony as a whole. Not only do the weavers learn new sources of food from these other birds, but they also get more lookouts for danger. When the extra rooms are empty, sociable weavers move between them. In the summer, they'll favor the cooler outer rooms, and in the winter, they'll migrate to the center. Fledglings, reared and nourished by the whole family, including older siblings, often stay in the nest, relocating to different chambers when it's time to leave their parents. Some weaver nests have been occupied for more than a century. Of course, the building and upkeep of such a complex requires constant coordination, and the bird chatter can be heard all around. If it gets too heavy, several tons sometimes, it can break its supporting tree. 5. Agglutinated foraminifera tests. If you've ever heard of agglutinated foraminifera, give yourself a massive high five. These single-celled microorganisms live way down in the ocean, like over 6 miles deep, 10 kilometers in the Mariana Trench. It's so deep and inhospitable. There's also nothing down there to build with other than the broken remains of algae and phytoplankton. These tests are presumed to be formed, or agglutinated, from the sunken, decomposed remains of coccoliths, calcium carbonate-plated algae, and phytoplankton from the sea's sunny surface. In other words, they build their homes from what's called marine snow, the matter that sinks down from above, rather like manna from heaven. As for the shells themselves, they come in different designs. Some are spirals like tiny snails, while others are tubular with chambers in a row. 4. Prairie dog gigacities. Prairie dogs are squirrels that live on the ground. Instead of burying nuts, they bury themselves. Black-tailed prairie dogs in particular live in sprawling burrows that humans call towns because of their town-like organization and population, many hundreds or more. They also tend to expand into cities, mega-cities, tens of millions of residents, and even gigacities, hundreds of millions. The largest recorded town, which covered 25,000 square miles, roughly 1/10 of Texas, had an estimated 400 million residents. 3. Termite mega-skyscrapers. In Australia's Northwest Territory, much of the dry plain landscape is dominated by the mounds of two termites. One is the compass termite, whose nests can reach heights of more than 10 feet and are built narrower along the north-south axis to avoid too much exposure to the sun. The other is the cathedral termite, whose nests tower above the ground, and any passing mammals, at heights of 15 feet or more. These are the biggest skyscrapers in the world, by far. If the millions of termites inhabiting them were our size, the mounds themselves, scaled up proportionally, would be taller than 3 Burj Khalifas, and in some cases more than 5. Both the compass and cathedral termites' mounds can last for a century, which, remarkably, could also be the lifespan of their queens. Again, scaling up for humans. This means that both queen and tower might last 7 millennia, despite being formed from just saliva, sand, and dung. 2. Ant empires. Sadly, the only way for humans to view the beauty of an ant's nest is to fill it with plaster, hot wax, or molten metal, killing every last one of its occupants. The resulting cast, though it'll cost you your soul, can be excavated and studied in detail. In this way, scientists have found a remarkable degree of planning and consistency in ant nest construction, which is all the more remarkable given they build in the dark without a leader or plan. And ants working on one side have no means of communicating with ants on the other. Really, ants work much like cells in an organism, and these organisms, the colonies, can get pretty big. Nests belonging to the same species in any given area tend to merge together in vast territorial systems, sometimes numbering hundreds of interacting colonies. Nest features typically include food storage chambers, brood chambers for eggs and the young, the queen's chamber at the heart, and waste disposal chambers on the outer edge for the deposit of dead ants and exoskeletons. These are joined by angled, vertical, or even spiraling shafts, which also provide ventilation. The variable depths and sizes of chambers provide the range of microclimates ant colonies need, particularly specialist species like those that farm fungi. They navigate their nests by chemical signage, similar to how they get around outside. 1. Bee 3D printing. Honeybees are more efficient than we could ever be, like termites and ants. Every bee in the hive has a purpose, but it's for their building work, not their social organization, that they get a place on this list, although the two are related. Darwin thought it the most wonderful of all known instincts, the way bees build their honeycombs with wax from their abdomens. Each consists of geometrically flawless hexagonal cells that fit perfectly into the grid, even while they vary in size to suit either drones or workers. What makes this even more remarkable is that honeycomb is built from different directions simultaneously. Bees starting from different sides of the grid in progress somehow join up with mathematical precision. This isn't robotic behavior, though. Studies have shown a high degree of adaptability during construction, with each bee cleverly adjusting its work to attain that geometrical perfection. They might, for example, use heptagons and pentagons where necessary, or alter the orientation of cells. A simple robot does not have such a level of adaptability and rate of error recovery, said entomologist Raghavendra Gudgakar. It is, according to the authors of one landmark study, a true architectural skill. So what do you think? Ready to ditch your apartment and move into a termite mound? Probably not. But hopefully, these incredible animal architects gave you a new appreciation for the natural world. If you dug this video, give it a thumbs up. Subscribe to the channel for more mind-blowing animal facts. And let me know in the comments which animal architect impressed you the most. What should we cover next? Hit that bell icon so you don't miss out on any new videos.